All right, here we have the problem 2 from the Central American and Caribbean Math Olympiad from 2017. And I kind of chose this problem partly because for a P2, it is surprisingly simple. The main thing that we're going to be using here is that the least common multiple of any two integers, a and b, is at most a and b. And this happens when the greatest common divisor of a and b is equal to 1. So when a and b are relatively co-prime, then the least common multiple of a and b is at its maximum, which is a and b. So, I mean, a times b. So we have that. And that's important, right? Because then that means that the least common multiple of a and 391 is less than or equal to a times 391. So firstly, let's do an assumption here, because we're trying to bound b, right? We're trying to find the minimum value of b. So it's best to try and kind of bound it at first. So let's do some assumptions here. Let's write, assume that b is less than 391, because we're trying to find the minimum, and that the GCD between a and 391 is 1. So basically that a and 391 are relatively prime. So from here we can kind of start constructing a large inequality that the least common multiple of a and 391 is going to be strictly equal to 391 times a. And that's going to be, by definition, right, because they're relatively prime. But then this is going to be strictly less than a and b, a times b, because we already have that b is strictly less than 391. So we have that this is a strict inequality, and this is the maximum for the least common multiple of a and b. So this is greater than or equal to the least common multiple of a and b. So from here we can just basically grab this and grab this with this strict inequality and just say that the least common multiple of a and 391 is greater than the least common multiple of a and b. And this basically is the opposite of what we're trying to look for, right? Because we're trying to find that the least common multiple of a and b is greater than this, not the other way around. So this is certainly not Pupusa. So this basically means that if we want to find a b that's less than 391, so the greatest common divisor of a and 391 is going to be greater than 1. And so from here we're going to try and break up the prime factorization of 391, which is just 23 times 17. So I mean, of course, you know, a is not equal to 391, and so a is either equal to 23k times k, or a is equal to 17 times k, where k is just like some positive integer, right? So now we just shrunk this down into two cases, and from here we're just gonna get like a nice solution from here on out. So let's do casework. Case 1, a is equal to 23 times k. So then that means that the least common multiple of a and 391 is gonna be equal to 391 times k. And then the least common multiple of a and b is going to be equal to the least common multiple of 23k and b. And so this is just going to be less than or equal to 23k times b. So now we basically grab this inequality and have that if the least common multiple of a and 391 is equal to 391 times k, then this has to be greater than the least common multiple of a and b. Yeah, bro, the other way around, my bad. It's less than, because this has to be less than this, right? Got it confused here. And this is less than or equal to 23 times k times b. So from here we just get that 391 times k is strictly less than 23k times b. And from here we can just cancel out 23 and k on both sides, just divide that, and we are left with 17 is less than b. So we have this as our first case, as our first bound. When a is equal to 23 times k, we have that 17, that b is going to be greater than 17, strictly greater. So then case 2, it's going to be when a is equal to 17k. And then we just kind of repeat the same process here. The least common multiple between a and 391 is just going to be equal to 391 times k. And then the least common multiple between a and b is going to be at most 17 times k times b. And then we can construct the inequality, which is that the least common multiple of a and 391, which is 391 k, has to be strictly less than the least common multiple of a and b, which is at most 17 times k times b. And from here we get that, we just get this, bring it all down, 391 times k then has to be strictly less than 17 times k times b. And from here we end with, divide 17 by both sides, divide 17 on both sides and divide k on both sides, and we are left that b is strictly greater than 23. And this is basically for our second case, but between both cases, case 1 and case 2, we have that, obviously this bound gives smaller values for b, and the smallest integer for b when b is greater than 17 is obviously b has to be greater than or equal to 18. And therefore, for the minimum value of b across all Pupusa pairs is when b equals 18. Something important is that we should verify this to make sure it works. So let's just grab, b is greater than or equal to 18. It's when a is equal to a multiple of 23. So let's just grab a is equal to 23 and verify that this works. And then least common multiple of a and 391 is just 391, and the least common multiple between a and b is just 23 times 8 since times 18, since these are relatively prime. 23 times 18, we don't really need to calculate that because this is greater than 23 times 17, which is conveniently equal to 391. So this works. That's basically the entire thing. And there are some trivial cases for when like a is equal to 1 and stuff like that, but I don't think it's necessary to prove it. A little bit all over the place, but I hope you understood. If you have any doubts, any questions, any concerns, and any alternate solutions as well, I would love to hear it. Please put it down in the comments. And yeah, I hope you enjoyed. I hope you learned something new. And again, if you have feedback, please let me know in the comments. And that's basically about it. Thanks for watching. Bye bye.